Happy morning, dear friends. Here's yours, Dr. Ajanta. Welcome to day 58 session. Today we are just going to discuss about Python decorators, and in that how you can create a decorator and why you should use it are all coming in detail. Before going to decorators in Python, see actually Python has an interesting features called decorators to add functionality to an existing code. And a decorator is a design pattern in Python that allows the user to add new functionality to an existing object without modifying its structure. So decorators are usually called before the definition of a function you want to decorate. So this is also called metaprogramming because a part of the program tries to modify another part of the program at compile time. And here are some prerequisites for learning decorators. So in order to understand about decorators, we must first know a few basic things in Python. That is, we must be comfortable with the fact that everything in Python, yes, even classes or objects and the name that we define are simply identifier bound to these objects, and functions are no exceptions. They are objects too, yeah, with attributes, and various different names can be bound to the same function objects. Okay, let me just see it with a small example. See here, dear friends, this is the first definition, that is the function which we are having the name as first, and here is the message as the parameter. And we are having two functions. One is C, actually the both function first and second give the same output, where here the name first and second refer to the same function object. Now things started getting wider. See here, when I just make use of this function, yeah, second is equal to first, and second also here we just going to have the same print as message hello, and let I just execute. Yeah, so this is the first one for hello and second hello for the second functionality. And see here, dear friends, when functions can be passed as argument to another functions. If you have used functions like map or filter and reduce in Python, then you already know about this. So such functions that take other functions as argument are called higher order functions. And here is a small example here, and we have already discussed it in the previous section. See here, dear friends, this is a function inc, and which just makes an increment of the given parameter, and the next one a dic, which is a decrement of that parameter. And when we just make use of this, and if we make a new function, that is operate, where what is the function if you are calling, whether it is an increment or a decrement, and giving the parameter, that is the attribute of whether it is x, and the resultant would be the function of that x, whether it is increment or decrement, and it just returns the value of that function. And see here, dear friends, when I just call the same operator function, and here I'm just giving the increment, and when I give the attribute value as 3, yeah, it is incremented by 1 and resultant would be 4. And when I just give the same operate function, and here the inner function, here what we just making it is a decrement, and the attribute value is 3, and see here the resultant is 2. And so here how the exact function is invoked and the result has to be resulted. And furthermore, a function can return another function also. Yeah, here is the example. See here, dear friends, when I just make use of this, return is returned, and this is the what it is a function which just makes one calling of one more function, and here it is a nested function too. Okay, let us just execute it. See here, dear friends, here we are just going to have only the new, which is a calling function of is called, and here the is returned is a nested function which is defined and returned each time if we called the is returned function. And finally, we must know about closure in Python. Yeah, we have already seen in the yesterday session. With that, let me just make the execution of this function. So as to this, we are having a two function. One is the normal function and to that of closer function, where this greeting it just going to return only the message welcome to Python. When I'm just making the uppercase decorator, here the parameter is a function and here warper is a nested function, whereas this function it just going to call the functions where each and every time it's just going to make it the resultant of the uppercase. And see here, dear friends, when I just make use of this uppercase decorator, and what is the exact function it is just going to call is the greeting, and here what it's just going to return, it is returning the welcome to Python in an uppercase. So here it is the resultant. Okay, let we make use of this example using a decorator. Let me just see it with a higher order function. See here, dear friends. So let me just compare the cell number 3 and to the current function. So here what we are just having is uppercase decorator is there, and with that we are now having a warper as an nested function. And when on just making the return warper, yeah, it is just going to have the upper decorator of greeting, that is the exact G functionality, so that we are just going to make use of that G, the function calling. And see here, when we need to have a higher order function, that is the decorator, we are just going to include only this exact function to get inclusion of the decorator. And once for all, here we are not just going to make use of this uppercase decorator here, because we have already made it inclusion as a function, as a parameter here, so that it is directly linked to that of the function where you are making it. And to that of this wrapper, yeah, it is just going to return the make upper class, and here it just makes the return wrapper. And let I just execute it, dear friends. So here, when on making use of the decorator, yeah, here the same functionality with a minimal functions which we are using here is the higher ordered function. Okay, getting back to the decorators again. See, functions and methods are called callable and they can be called. Yeah, in fact, any object which implements the special call, which we just say double underscore call method is termed callable. So in the most basic sense, a decorator is a callable that returns a callable. Basically, a decorator takes in a function, adds some functionality and returns it. So here what it just going to take is, it just going to take here as a functions, and here what it just making an addition is a nested functionality, and then it returns to that of same function. Whereas see here what it just adding is, here we are just going to have an addition of I am ordinary. And let I just execute it. See here, dear friends, here it is only the function, and we have created that ordinary as the callable function. And even though you can just make it much more decoratable by using the same initiative with the another function also. And in the exact example above, see here, this make pretty is a decorator, and in the steps where we are just going to make is, that is pretty equals make pretty of ordinary. See, the function ordinary got decorated and the returned function was given the name pretty. The given the name is pretty. And we can see that decorator functions added some new functionality to the original function. Yeah, this is similar to a packing a gift. So the decorator acts as a wrapper. The nature of the object that got decorated, actually gift inside, does not alter. But now it looks pretty since it's got decorated. So generally we decorate the function and reassign it as ordinary equals. Here we are, ordinary equals that is make pretty of ordinary. So this is common constructor for the reason, and Python has a syntax to simplify this. And see here, dear friends, we are just making it with a symbol at symbol here. Okay, along with the name of the decorator function and placing it above the definition of the function to be decorator. And here how you can just make it, which is equivalent to this. So here, see here, dear friends, at make pretty is our decorator, and here we are making use of at make pretty, and where it is the same equivalent to this line, that is ordinary is equal to make underscore pretty of ordinary. So this is just as syntactic sugar to implement decorators. Fine. Let me just see decorating functions with the parameter. See, the above decorator was simple and it only worked with functions that did not have parameters. What if we had functions that look in parameters, like here, see here below there was a parameter is there. See, we are having a divide function and we have two parameters, a comma b, and how it would be callable. So here if we just give two parameter a slash b, yeah, it is going to be 2 by 5. Oh, and how it just going to be is 2 slash 0, and here it is the 0.4 is the answer. And if you're just giving anything to that of 0, yeah, anything divided by 0, it is going to give you an error. Fine. So this is how you are using a functions with a parameter. Now let's make a decorator to check for this case that will cause the error. Exactly. So same, let me just make use of it. See here, dear friends, here smart divide is a function, and here inner is the nested one. And whereas when I just make use of I am going to divide a and b, this is the exact function. Okay, let we have, oops, if we just can't divide with 0, yeah, if anything it just gives a 0. Here it is the exact message, and what is just going to return a is the function a comma b. And here it is the definition, that is the callable function divide, and we have initiated the decorator here. Okay, let I just execute it, dear friends, kindly have a look of it. And here the same example we are just going to make it, and see I am going to divide 2 and 5, and here is my result. And now see here I am going to divide 2 and 0, and see, whoops, cannot divide with 0. So this is what the exact resultant when you make use of a decorator. So this new implementation will return none if the error conditions arises also. Okay, let me just make use of this example in a new functionality. See here, dear friends, we can decorate that take parameters also. Okay, so here is a function decorate with parameters, and we are just going to make a wrapper accepting parameters, and here it is the statement under the functions. And what is the exact decorator? Yeah, here we are having, which is with the at symbol, is the one which is just going to have the decorator. And see here, dear friends, when on functions that is inside the decorator is the same as the parameter of the function, it decorates. So taking it into account, now we can just make a general decorate that works with any number of parameters. So let I just execute it. See here, dear friends, here it just makes the print of full name So it just getting the attribute of the first names, last name and the country. And with this functionality, it just goes to the nested function, which is just accepting parameter, that is wrapper accepting parameters, and both the things which is combinedly with a decorator with parameters. This is how you can just make use of the function of decorators. And here is one more example, just has an first decorator and a second decorator, which is just having more than one decorator. And both the things here we have used as a decorator, that is order with decorator is important in this case, that is which one should come first. That order that also has to be specified here. Okay, so here we are having two decorators. One is the uppercase decorator and next one split string decorator. And with that functionality, what we want here, we want to have the function call of greeting. And what it's just doing is welcome to Python. And see here, the first one, it just going to have the split string decorator. So that is what the first one. So it is just going to split the exact string, that is welcome separately, to separately, and the Python, which the exact returned to be in a splitted string function. And once for all, if it is received, yeah, it is just going to be made it in a uppercase. That is what the first decorator here. Okay, let I just execute it. See here, dear friends. So here the exact string was splitted and it is converted into uppercase. Okay, dear friends, let me just have a small look of built-in higher order function. Some of the built-in higher order functions that we cover in this part. Actually, yesterday we have just seen few of the functions, and today we are just going to have the map, the filter, and few of the functionalities is that. Okay, let me just see one by one. First of all, map function. See, the map function is a built-in function that takes a function and iterable as parameter. And here it is the exact syntax of the map. So here what it that iterables, the iterables can be anything. It can be of a list or a dictionary or a tuple. And here the function which is actually here, it just takes a function and iterables as a parameter. So here what it's just going to have is the number, and that has a variable, it is a list variable. And what it's just going to do, the function is square. Okay, and with the number squared is the exact function where it just makes the map of square and number. And kindly have a look of it, dear friends. Here it is 1 2 3 4 and 5. So we are just going to get the returns of the squared in a list format. And see here, dear friends, we are just going to make it in a two-way type. One is by using the map by specifying the square, that is the function. And even though you can just specify this function, or you can have a lambda function, that is an anonymous function, without just making it as a call of or a defining a function. Okay, so both the ways, yeah, let I just execute it. Yeah, we are just getting the same in both of the functionality. Okay, let I just go for one more example in map. See here, dear friends, here we are just having a string 1 2 3 4 5. It is a list variable, and now I just want to convert it into a number. And my exact functionality here, it is a int. And what I just want to have it is in a number length, which should be printed in a list manner. Okay, so here the map function, which it just make each and everything to be mapped with the function unto that of iterable parameter. And see here, dear friends, we are just getting the same thing in a integer, whereas the thing is converted into a integer. Fine. Next, let me just have the functionality of making it into a uppercase. Yeah, here too we are having two method of functionality. One is by making a function and then defining a function and calling it as in the map function. And the another one, yeah, you can directly declare a lambda name, that is an anonymous function, to make it executable. And here what we need is change to uppercase. Yeah, whatever the string is present provided as in the list has to be converted 8 into uppercase. So let I just execute it, and here we are just getting two outputs. This, yes, one is from the defined functions change to upper, and the next one is by using the lambda function. Here what actually map does is iterating over a list. So for instance, it changes the name to uppercase and return as a new list. That is what it just doing here. Okay, we move on to the next one, filter function. And see here, dear friends, this exact filter function calls the specified function which returns boolean for each item of the specified iterable, which is a list. So it filters the items that satisfies the filtering criteria. And here I have just provided the exact syntax, yeah, filter of the function and to that of iterable. And kindly have a look of it, dear friends. See, the number is the exact variable, and it's just going to have the list of 1, 2, 3, 4, and 5. And what I just want is I want to make use of this function. I have defined a function that is even. So here what I need is only the even numbers from the list. It has to be extracted. Okay, so here how I'm just making use of it by filtering, yeah, is even function which I have defined. I'm going to make a call of it as a function, and the numbers which is in the list, which is a iterable, that is being the parameter. And once for all, when I'm just going to have the resultant, yeah, that is also to be in the list manner. Okay, vice versa, let me just have the odd numbers too. Yeah, we need to have a odd number from the same list. So here how we are just going to make use the same is odd number, and here the function which we are just making defined is to extract only the odd number. Yeah, among this list 1, 2, 3, 4, 5, we are having three odd numbers. One is 1, 3, and 5. Yeah, and next one, see here, dear friends, you can also have one more last example, that which it just makes the iterable of the length that is greater than 5. So here what it just do, it first take each and every string as one among the parameter and check whether the exact string is, the length of the string is more than 5 or not. So if it's so, which is the highest, that is not highest, so which is the exact name, here we are just giving the names as the string. So here what it's just going to give is the exact string which is the length is more than 5. Yeah, it is going to be the returned list, and here is the output. I just may scroll up. Yeah, here is our output. And dear friends, kindly have a note of it. Here I have just provided you few of the functions that use higher order functions, and the closures and the decorator. Yeah, the closure, yesterday we have discussed it, and some of the exercise that includes the higher order functions, closures, and decorators too. So kindly have a hands-on on this every exercise, and hope you just see in tomorrow's sessions. Thank you. Have a nice day. Bye, dear friends.